This is our last presentation of the morning. We are going to come back here after lunch at 2 to continue with the afternoon session. But now we have a very different presentation from the last two ones. So we have Paul Davies. He is a theoretical physicist who dabbles into everything in theoretical physics. He's an incredibly broad-range thinker. And he's the author of many, many popular science books as well, including one called The Eerie Silence, which is about the existence or non-existence of extraterrestrial intelligence. And so this is going to be the topic of his presentation today. Paul is the director of the Beyond Institute for Fundamental Questions at the Arizona State University. So I'm really, really happy that he is going to be with us. Unfortunately, he had a family issue that prevented him from being here in person. But thanks to modern technology and quantum physics and electromagnetic radiation, we are able to actually see him, even though he is in Arizona right now. So, Paul, thanks for waking up early for us. And please go ahead. Thank you.
Thank you, Marcelo, for that kind introduction. And hello, ladies and gentlemen. I'm sorry I can't be there in person. I'm talking to you from my office at Arizona State University. And I gather some of the screen is obscured by little boxes, but it won't matter because I'll carry the day by the power of my oratory alone. But the pictures are generally pretty easy to interpret, and there's not a lot of text. So let me start by saying that whether or not we're alone in the universe is one of the oldest and biggest of the big questions of existence. But for most of human history, it lay entirely within the province of theology and philosophy. But in recent decades, science has also made a contribution. For about 50 or 60 years, astronomers have been sweeping the sky with radio telescopes in the hope of stumbling across a message from ET. Now, this wasn't done on a whim. Back in the 1950s, when radio astronomy was in its infancy, it dawned on a few scientists that these instruments had the power to communicate not just across terrestrial distances, but literally interstellar distances. And so that in the unlikely event that there was some advanced alien civilization out there in the galaxy trying to communicate with us by radio, then we would have the means to pick up their messages. And that whilst the probability of the success of such a project would be small, if nobody tried, then it would of course be zero. And the challenge was taken up in 1960 by a young American radio astronomer, Frank Drake. And this is where I'm pressing to advance the slides and they're refusing to advance. Just have to bear with me. I don't know why that is. Yeah, there we go. It advanced at mine. I hope it advances at your end. So here's Frank Drake standing in front, a rather grainy picture, I'm afraid, standing in front of the Green Bank radio telescope, which he used in this pioneering search back in 1960. And so he founded a field of endeavor that is now known as SETI, the Search for Extraterrestrial Intelligence. And it really asks the question, is there anybody out there, and how might we determine? After 56 years of this SETI search program, which has expanded greatly since Frank Drake embarked upon it, there is nothing but an eerie silence. And you might feel that if you try this for a few decades and get nowhere, that you give up, the field would evaporate. And indeed, it's limped along on a shoestring budget for many, many decades, just a small heroic hand of radio astronomers who have carried on in spite of these null results. But the field was transformed just over a year ago with an interesting press conference held at the Royal Society in London by Yuri Milner. He's a Russian philanthropist, lives in California. And at this press conference, you'll notice Stephen Hawking and Martin Rees and a now somewhat aging Frank Drake sitting there. It's not obscured by the little boxes. They announced that $100 million will be donated by Yuri Milner to revivifying this SETI program. And it's called Breakthrough Listen, because it's an attempt to listen in this time-honored manner. But a few months after that, a second initiative was announced by Yuri Milner, this time at a press conference in New York, also involving Stephen Hawking. And this is called Breakthrough Starshot. And these two breakthrough initiatives have to be considered together. I'm just going to very briefly explain what the intention of Starshot is. The idea here is to send a swarm of microchips to the nearest star system, Alpha Centauri, using very powerful ground-based lasers. Most of you have read about this, I'm sure, in the press as an artist's rendition of what this might look like. So these lasers might be based, for example, in the Atacama Desert, and will be used to direct enormous pulses of energy out into space, where these microchip payloads will be tethered to little parachutes, rather like this picture here. And such is the powerful force of these lasers that it will propel these payloads to 20% of the speed of light in just a minute or so. Enormous acceleration, of course, but with something the size of a microchip, this wouldn't present a problem. And at 20% of the speed of light, it would take only about 20 years for these tiny objects to reach the Alpha Centauri system. Of course, they'd be going very fast when they got there, but the miracles of modern technology mean that we would still get a lot of interesting data back from that system. And so the attempt to answer the question, are we alone in the universe, suddenly has an injection of $200 million worth of capital. And I think we can expect all sorts of interesting developments in this field in the next decade or so. But I'd now like to look backward to the history of discussion of this fascinating subject, because, of course, it wasn't in the 1950s that people first began thinking about life beyond Earth, and in particular intelligent life. Speculation about whether there are other sentient beings out there in the universe actually goes back to ancient Greece. But in the modern era, a lot of people identify the beginning with the words of Giordano Bruno, who in the late 16th century wrote that, like Earth, these other worlds contain animals and inhabitants. Now, Bruno, of course, met an untimely end. He was burned at the stake. But my theologian friends say this wasn't the heresy that resulted in that. There was many other things that he'd said. But the truth is that speculating about life beyond Earth, particularly intelligent life, was one fraught with danger because of its theological implications. However, there followed about 2 or 3 centuries of actually rather lively debate within the Christian Church about the impact of the discovery of alien sentient beings, the impact on religion and how we should understand that and incorporate that into the nature of Christianity. I think other religions were less affected because it was in Christian Europe that most of this speculation took place. So a rather fascinating history, which I don't propose to summarize here due to lack of time. So let me leap right forward to the scientific era and the speculations of Percival Lowell. I feel obliged to mention this because here I am in Arizona, and it was at Flagstaff in Arizona that Lowell sought to build an observatory. Here you see a picture of it in the present day. And the purpose of this observatory at that time was precisely to search the planet Mars for signs of intelligent life, and in particular to see whether Mars had canals So there have been speculation that the surface of Mars is crisscrossed by straight lines that an Italian astronomer, Schiaparelli, had called canali, just meaning channels, but it caught the popular imagination that maybe intelligent Martians had dug these canals, and Lowell himself saw plenty, and he produced lots of maps, and here's one from his book, published about the turn of the 20th century. And he was quite unequivocal about this. He wrote that Mars is inhabited by beings of some sort or other we may consider as certain, as it is uncertain what these beings may be. And so at that particular time, it seemed plausible enough that Mars might be an inhabited planet and indeed inhabited by intelligent beings. This surely was part of the reason that H.G. Wells at about that same time wrote his War of the Worlds fantasy. Well, in the modern space age, many spacecraft have gone to Mars, and alas, there are no canals. There are no Martians, intelligent or otherwise, although it's just possible that microbial organisms may exist beneath the Martian surface. That's an open question. But the truth is there are no canals, no civilization on Mars. It's a freeze-dried desert bathed in deadly ultraviolet radiation, and as I like to say, in the words of Elton John, not the kind of place to raise a kid. So the solar system in general is almost certainly a write-off when it comes to any sort of advanced form of life. But of course, we're just a tiny little corner of the universe. Our galaxy alone contains hundreds of billions of stars, many of which will have planets. And we know that now because of missions like the Kepler satellite here, which is finding large numbers, or was until recently, it's now not very functional, finding large numbers of what we call extrasolar planets. These are planets going around other stars. And based on the statistics of this, it's been estimated, here you see that billions of Earth-like planets exist in our galaxy. So the great interest from the point of view of astrobiology is looking for Earth-like. It's a little vague as to what that means exactly, but roughly speaking, that it should be a planet like Earth going around a star like the Sun and have liquid water on the surface. That's about all at this stage. It's clear that there's plenty of real estate out there in the galaxy on which life as we know it might form. Of course, we can speculate about alternative forms of life on bodies which would be hostile to terrestrial life, but I'm not going to get into that here. So plenty of real estate. So does that mean, therefore, that the galaxy is teeming with life, and some of which will be intelligent? Well, no, it doesn't, because habitable does not mean inhabited. It's astonishing how many commentators, including some distinguished scientists, fall into the trap of thinking just because life could exist on a planet, just because an Earth-like planet could host life, then it is inhabited. But of course, for a habitable planet to become inhabited, life has to arise on it. That is, somehow, non-life has to turn into life. A mixture of chemicals has to become a living thing. How did that happen, say, here on Earth? The answer is we don't know. When I was a student back in the 1960s, the mood at that time was very different from today. I was interested in looking for, not personally, but interested in the search for life beyond Earth. And one might as well have professed an interest in looking for fairies. Everybody seemed to think that life on Earth is a bizarre freak, a chemical accident of such improbability it would never happen anywhere else in the galaxy. Today, well, Crick's words here may be blotted out for you. It says life seems almost a miracle. So many of the conditions for it to get going. But then 20 years later, Christian de Duve in his book Vital Dust was able to write that life is almost bound to arise wherever physical conditions are similar to Earth. And he had this ringing phrase, life is a cosmic imperative. So here are two distinguished scientists taking completely opposite points of view about how likely it is that non-life or turn into life. What did Darwin have to say on the matter? Well, interestingly enough, he refused to be drawn. He said it is mere rubbish at thinking at present of the origin of life. One might as well think of the origin of matter. And if you remember nothing else about this lecture except what I'm going to say now, then this is the key point. If we don't know the process that transforms non-life into life, we can't estimate the probability for it to happen. That is, that you can't estimate the odds of an unknown process. That's probably the punchline blotted out at the bottom of your screen. We don't know if it's a bizarre fluke or chemically inevitable, but if we don't know what did it, we can't possibly come up with an answer as to how likely it is to happen. Now, the important point here is that Darwin gave us a wonderful theory to explain how once life gets going, it can evolve to more complex forms, for example, intelligent life. We still don't know, given a planet with microbes, how to compute the likelihood that it will eventually produce intelligent life. We don't know how to do that calculation, but at least we know the process. It's called Darwinian evolution. We know the process, but we do not know the process that turned non-life into life. So I'm really stressing this point because there's a lot of silly commentary around the subject, and scientists should know better. We simply cannot state one way or the other how likely it is that we're going to find life out there of any sort, and let alone intelligent life. The big step, the biggest unknown, is that non-life to life transition. So how can we improve on this? How could we test this uplifting notion of the cosmic imperative? We could look for a second genesis. All we need to do is find that life has happened more than once. If it's happened twice, surely it's happened many, many times. What is the most Earth-like planet we know? It is, of course, Earth itself. Life does arise with inevitability, as Christian do suggests, and surely it should have started many times over right here on our home planet. How do we know it didn't? Has anybody actually looked? And it turns out that until I ran a workshop on this at the Beyond Centre back in 2006, almost nobody had thought to ask this question. Nobody had tried to look for a second genesis on our home planet. So what I'm talking about here is not just another exotic branch on the known tree of life, but a separate tree right under our noses, or possibly in our noses, because I'm talking about microbial life only. The microbial, almost all life on Earth is microbial. We tend not to think of that because we see the big things, but most species are microbes. We haven't scratched even the surface of that microbial realm. The vast number of microbes, you can't tell by looking what they're made of. You've got to delve into their biochemical innards in order to determine if they are life as we know it. And so this has led to the idea of the shadow biosphere that intermingled among the microbial realm of terrestrial organisms that we know, life as we know it, might be organisms that we don't know, that is sufficiently biochemically different that they could have arisen only from a separate genesis, a separate origin. So that's one line of attack, aliens under our noses or in our noses. But let me return to, not microbes, but return to the question of advanced intelligent aliens. There is, of course, an obvious problem with traditional SETI of just turning a radio telescope on a likely looking star and hoping to pick up a message, and that is that the aliens don't know we're here. Why is that? Well, supposing there's a civilization about 1,000 light years away, and that's, if you ask, say, Frank Drake, a SETI optimist, that would be his guess. The best case scenario would be within that sort of distance, 1,000 light years. These aliens see Earth as it was 1,000 years ago, not as it is now. And there were no radio telescopes 1,000 years ago. They may detect signs of intelligent life, for example, in China or early agriculture. They might deduce that there is intelligent life on Earth, and they may figure that 1 millennium soon we would have radio technology. But it would make no sense for them to be beaming messages at us until they knew we were on the air. And our first feeble radio messages have only got about 100 light years into space so far. So in another 900 years, these hypothetical aliens may pick up our first messages and begin beaming messages back at us. So we've got about another 900 years to wait for a deliberately beamed message, if indeed there are any aliens out there. So that's an obvious reason why there should be an eerie silence. However, let's not despair, because we may answer the question, are we alone in the universe? Not by picking up a deliberately beamed message, but by simply coming across signs of alien technology. So what we're really looking for is not so much a message, but any footprint or signature of technology that is non-human. And I'll give you some examples. Is there anything out there that is fishy? If you saw something like this, it certainly looks fishy to me. This would be a clear giveaway. So would something like this. You'd have to be very lucky, of course, to spot any in-your-face technology of that sort. However, there is an idea that goes back to 1960 of Freeman Dyson, often called a Dyson Sphere. And he conjectured that an energy-hungry advanced civilization might pull its planetary system to bits, a bit drastic, and create a spherical shell around its star that would trap all of the light of the star to run its industry. And although that's obviously a bit of a wild speculation, just a few months ago there were press reports that something like this may have been discovered, that there's a particular system, a particular star about 1,500 light years away that's got funny stuff going around it. Seems to not be planets, it seems to not be a cloud of comets. Nobody really knows what it is. Could it be some sort of alien megastructure, alien advanced technology? Well, probably not, but it's fun to think. This is the type of thing that I have in mind in saying we need to broaden the search for in SETI. We need to get away from the idea of deliberately beamed radio messages and look for these other signatures of civilization. There's another example that my friend John Webb, an astronomer in Australia, kindly drew my attention to, and this is Przybylski's star. It's impossible for me to pronounce it. I was in Poland a couple of weeks ago, and several people kindly told me how to pronounce this tongue twister name, but I'm afraid I've forgotten. But anyway, this is a star. It's a pity that the numbers actually at the bottom of the screen, probably obscured, but the point is that it's chock full of radioactive elements: uranium, neptunium, plutonium, even californium and einsteinium. This is truly extraordinary. Nobody knows what's going on here. I hope you can see at the top right of the screen my humorous conjecture. Maybe there's an alien civilization that's got the license to deal with nuclear waste in that part of the galaxy, or is just running a nuclear industry and piping the energy to its neighbors. Maybe this is their attempt at SETI, drawing our attention, or maybe it's just a student project that went wrong. But it's another example of looking for anomalies wherever we find them, and not being fixated on radio messages. I'm not giving up on radio entirely. There's a different concept of radio SETI, and this is coming to a conclusion in case you're wondering. There's a different concept, and that is the notion of the beacon. A lighthouse sweeps the horizon and sends out a simple pulse, and it's not directed at any particular ship, just for the benefit of whoever is out there. And in the same manner, maybe an alien civilization has created a beacon, either laser or radio, that's sweeping the plane of the galaxy and comes around, every few months or every few years. And that's a different search strategy. It means you have to just point your telescope at a patch of sky and wait for months or years in the hope of seeing a repeating transient pulse. And one such transient pulse was picked up in 1977. It's called the WOW signal, because the scientist concerned, when he looked at the record from the radio telescope, wrote WOW in the margin, because it was a very strong, still unexplained pulse. from a certain part of the galaxy. Nothing strange has been seen there since, but then not a great deal of time has been spent looking. So let me just summarize all this. Why do we do this thing, SETI? It is, of course, a needle in a haystack search without any guarantee that a needle even exists. And I think I'd like to draw myself a profound conclusion that if Earth does have a shadow biosphere, as I've suggested, then we could conclude that life is widespread in the universe. It is a cosmic imperative. It'll be a fundamental feature of the universe and not just a local trivial aberration, as some people think. So we will be part of intrinsically bio-friendly universe, and there will be as it were, at home in the universe, a universe that has laws which encourage the emergence of life, and I like to believe mind, as part of the natural unfolding of the great cosmic scheme of things. So I think the search for SETI is in effect an attempt to understand ourselves, who we are and how we fit into the universe. And I'll give the last words to Frank Drake himself, who pioneered this field. SETI is a search for ourselves, who we are, and where we fit into the universe. And with that, I shall conclude. Happy to take questions.
Questions? Okay, hold on. Yep.
This is a non-scientific question. Many people, most recently Stephen Hawking, has said it'd be foolish for us to reveal our existence to any aliens, as they would have far superior technology, and usually that's bad for the people with worse technology.
Yes, I completely and utterly disagree with what Hawking said, and many other people have made the same point. And it's very simple to see why this is a rather silly thing to say, because our planet has been here for 4.5 billion years. If any aliens wanted our planet, they could have come and taken it at any time during that history. They surely don't want our planet for us, that we human beings would have nothing to offer them. They might well like planet, but if they've got the technology able to detect our signals, have the technology to detect all of the physical conditions on the planet, they don't need us to invite them in. If they were hostile like that, they would just come, and they haven't done in 4.5 billion years. So it really seems to me absolutely silly to worry about advertising our presence, which of course we're doing anyway every time we have a television or radio broadcast or use radar, which is the most powerful radio pulses leaving Earth. So the one thing we don't need to worry about, I think, is an alien invasion triggered by an attempt to communicate. Of course, there may be an alien invasion, but then why didn't it happen? Why, it would be a bit of a coincidence if it happened just at the time human beings started getting interested in aliens, that they got invaded. 4.5 billion years, remember, our planet has been here.
Hello, hi. I'd like to ask, so you mentioned that radar is one of the pulses coming out of Earth.
Yep.
So in the same way that you mentioned that we could look for anomalies around other stars, would you expect that someone would see the anomalies generated by our technologies, you know, radar and other things, satellites even around the planet? Would they notice this in the same way that could we notice someone else's technology that would be in the same spirit as ours?
Right. There's been a lot of discussion and calculations done about could we pick up powerful radars, say, from a civilization around the nearest star. It turns out that even with our finest radio telescopes, that's tough because if these pulses are not deliberately directed towards us, it would be most unlikely that we would detect anything. So example, we couldn't detect domestic TV or radio stations with the power of our own transmitters on even the nearest star. So it's got to be directed towards us. The general, it highlights really a general difficulty about all of this speculation about what to look for. And that is there's a natural tendency to take human technology and extrapolate it by a few years and assume anything that we can do, they can do better and slightly more powerfully. But of course, even during my lifetime, this technology has changed. As Frank Drake himself likes to point out, that the early era of radio communication is sort of fading away. Most of our communications now take place in optical fibers. They would leave no, send no imprint out into space, that our satellites are directed downward, not upward, and we still have the powerful radars, but for how much longer? It just reflects our present political circumstances. And so this means that in the SETI game, it pays to be as open-minded as possible, to look for anything, to search any database to which we have access that costs little money. And I've got many examples I could talk about at length about things we could search, where it seems sort of slightly crazy to imagine we'd see the hand of any alien technology in that database. For example, like genomic databases of terrestrial organisms. And you might think, well, where would you ever see the hand of intelligence in that? And the truth is, you can if you look at the genome of Mycoplasma laboratorium, because that was created by Craig Venter, and his email address is in the genome of that organism. So maybe ET's email address is lying somewhere in a terrestrial microbe. All we've got to do is search the genomic database. So that's one example of a totally wild and crazy idea which costs almost nothing, because that data is free on the internet. So that's the type of thinking I think we need, is to find ways of creatively searching already existing databases for who knows what. I say anything fishy.
Any questions? Oh, Adam. Okay. And Seth.
Paul, thank you for a wonderful talk. I'm wondering, in the sort of spirit of what we've been talking about at the conference of the overlap, taking Frank Drake's final quote here, how does, it may be a long time before we get any data about actually whether there's another civilization. On the other hand, we have this enormous explosion of astrobiological information, including the exoplanet data. How does the activities of SETI or of astrobiology, how should it change our own narrative of who we are and what we're doing to the planet, particularly because we're facing this planetary transition that we've driven?
In my book, The Eerie Silence, I tried to address that issue because, of course, SETI is a frustrating subject. We may wait for decades and decades and still find nothing. And meanwhile, we can reflect on the consequences to our society on Earth should this discovery happen. And if it happens, it may be rather sudden, and so it pays to be prepared. And clearly there are impacts. My main interest is the impact on our philosophical and indeed theological circumstances. That, what does it mean for us as humans? How should we think of ourselves? And this is where I see a curious inversion, because the reason that Bruno came to a sticky end and others felt it was dangerous is because of the belief that human beings are a product of an act of special creation, as opposed to having evolved as part of Darwinian evolution. Now most people accept that we are the product of nature. It seems to me that things have flipped around the other way, that now evidence for purpose in nature, evidence that there is an underlying bio-friendly scheme of things, would come from exactly the opposite, from finding that the universe was teeming with life, that this transition from non-life to life would be a cosmic imperative. I think that, whilst I wouldn't go so far as to say that is a religious belief, it is certainly something of that nature. It's something that informs us about our place in the universe. And so for me, a bio-friendly universe is one in which I would feel at home. And so we don't even need to go as far as intelligence to already pick up the profound importance of that. If, on the other hand, it turns out that life is limited to Earth, if we are just some sort of bizarre freak, a chemical quirk that's unlikely to be repeated anywhere else within the universe that we can see, then that has other implications, because while that would depress me and make me feel, well, maybe there's nothing more, that maybe life is not special, it's just another phenomenon in the universe, and that we are of no significance. On the other hand, it would mean we would probably take stewardship of our own planet more seriously. So I think there are these sweeping implications, just reflecting on what the situation might be should we discover this or that.
Paul, it's Seth here, and I apologize if I have mentioned this to you before. I mentioned it to some people last night, but I do have an explanation here that unifies a bunch of these questions, so which I managed to get published as a letter to the New York Times a few years ago. So we've already heard about, today we talked about dark matter, cold dark matter makes up 25% of the matter in the universe. We know about it from these rotation curves of galaxies. We don't know what it is. Dark energy makes up 70% of the energy universe, pushing the galaxies apart at an accelerating rate. Anyway, and then you're asking, where are the aliens? My modest proposal, as I entitled it in this letter, is that the cold dark matter is the aliens. And the reason that we can't detect them is they just don't want to be detected. It's not that they're made out of some funny stuff, it's just that they're very smart and we can't detect them. Okay, so good. So we have 2 out of the 3 of where are the aliens in cold dark matter. So now you may ask about the dark energy. And this is also very simple. Again, it's a sociological explanation, not a physical explanation, which is that why are the galaxies accelerating away from each other? So the aliens, while not actively hostile, would prefer not to live in our neighborhood. So this is, there's a subtle way of telling us to get lost. It's, alien flight in the cosmic real estate market. Anyway, I wrote a letter to Dennis Overby. I managed to get it published in the Times about this. Though he did point out, I want to say, I also found out that despite the fact this was entitled a modest proposal, that it turns out that irony is something that's lost on many of the readers of the New York Times.
Look, I don't think there's any answer to that.
I doubt it. So, Paul, do you want to close up making a few remarks about the fine-tuning question? Because you just briefly mentioned it, and it was touched upon yesterday on a talk on the multiverse. So if you could mention and explain a little bit about what is it and why is it a problem?
So, sorry, you're asking me to just to talk a little bit about fine-tuning?
Yeah.
Yeah, so it's very important that everybody there understands that I've been talking about not whether life in the universe is possible, because here we are. Obviously, the answer to that is yes, but whether or not the universe is, as it were, optimally biofriendly as opposed to minimally biofriendly. That is the universe such that life pops up more or less wherever it can? And that's the nice at home in the universe view that I would like to believe in, but for which we have absolutely no evidence at this time. But your question concerns going one level deeper, which is why is the universe such that it gives rise to any life in the first place? And that's a whole set of ideas. I've written a book on that too, called The Goldilocks Enigma. Why is the universe just right for life? And that really concerns what is often called anthropic selection, or the anthropic principle, that the universe could have been otherwise, that the laws and initial conditions could have been different. But had they been different, almost certainly no life would have arisen. And so, of course, we don't live in such a universe because it would be biohostile. We have to live in a biofriendly universe. But in order to make that argument work, it's merely necessary to have one civilization or group of sentient beings, which could be us. We could still be anthropically selecting a biofriendly universe, even if we're the only ones in it, within a very large volume. So I think that is really a separate set of issues as to whether the universe, why the universe permits any life, why it is minimally biofriendly, versus the optimal biofriendliness that I've been talking
Okay, perhaps last question. Okay, hold on.
Okay.
Good morning, sir. So for many people my age, our first introduction to Frank Drake was the movie Contact with Jodie
Right.
Foster and Matthew McConaughey. And one of the great romantic scenes of the movie, she's going through the Drake's equation, walking him through the math, and then coming up with completely the wrong answer, which, there's nothing sexier than bad math. But my question is, as you stated, the Drake's equation is not practical in search for life, as we don't have the answer for how life origin begins. Is there a way to estimate the number of inhabitable planets in the universe, and does that help narrow the search for intelligent life?
Well, I tried to make the point that we merely need to discover just one other sample of life, because it would be extraordinary if we lived in a universe in which life just happened twice, as opposed to once or many, many times. And so we really want a second genesis. We need to find a second sample of life. Some people think that we may find such life on Mars, and it's true. We may go to Mars and find that there's microbial life, but unfortunately Mars is contaminated both by human space exploration, but also over its history by the trade of rocks between Mars and Earth. Mars rocks come to Earth, Earth rocks go to Mars. These are impact ejector. Comets and asteroids hit these planets and splatter rocks all around the solar system. And microbes can easily be conveyed in these rocks from Earth to Mars and Mars to Earth. So it's probably a waste of time looking for a second genesis on Mars. We might just as well look for it here on Earth in the manner I've described, by looking for a shadow biosphere. Just one alien microbe here on Earth. By alien, I don't mean necessarily from space. I mean it's life, but not as we know it. Just one example would do. If life had happened on Earth twice, surely it's happened all around the universe. So that's why I put such great emphasis on what is, on the face of it, a fairly straightforward task, to look for a second form of life here on Earth. The other way that people talk about, get excited about, is that we have this inventory of planets now, and within a decade or two, telescopes, even ground-based telescopes, should have the capability of imaging these planets and getting spectra from the atmospheres of them. And so some astrobiologists are excited that maybe in 20 years, we will pick up the telltale signs of, say, oxygen and methane together in the atmosphere of an extrasolar planet. And people say, well, that would be a signature of life. Unfortunately, it's not really that simple. It's very hard to come up with a sort of minimal list of things you might see in these extrasolar planet atmospheres that would be a dead giveaway for life. Obviously, if you saw industrial pollutants, or you picked up plutonium or something like that, then that would be a much stronger signature. So I put my faith actually in discovering a second genesis here on Earth. I think, although that's a long shot, it's if biologists are right, or if the enthusiasts are right, that life really does pop up all over the place effortlessly, because the transition from non-life to life is just some sort of routine thing, well, then we should see evidence for more than one form of life right here.
And okay, so now we break for lunch so we can eat other forms of life and come back here at 2 o'clock nourished and happy. Thank you. Bye-bye.